This video covers the last chapter in the Collins GCSE Higher book, and it's on vectors. Now, vectors come in two forms. Vectors written as a column, vectors as column vectors. Now, we've come across these before when we did translations. So you'll remember with translations, you can write a translation like this. Yeah, and what this tells you is that we go, this would be 3 squares left. You basically move your shape 3 squares that way, and then the 2 means 2 squares up. Yeah, which would be 2 squares that way, and then you move your shape 2 squares up. So you do both of those things together. Now what we can do in this last chapter is that we can give it a letter, a bit like functions where you say, right, a function is a letter. So we might say, right, every time we do A, it means do this. We might have another vector, and we might use some different numbers, and we might say, okay, every time that we see the letter B, this is what we do. Now what we can do, we can combine these. I can say, right, what's A plus B? So we just add the vectors together, like this. So you just add the top numbers together, you add the bottom numbers together. So this would give me 4 and negative 3. I could say, right, okay, let's double the first one. What do we get? If I did 2 lots of A, well, you just double the numbers. So I'll get negative 6, 4. I could even do more than that. I could say, right, let's do 3 of A and then add 2 of B. Now what does that give me? Well, so that's going to be 2 lots of whatever A is. Sorry, 3 lots of whatever A is. And then I'm going to add 2 lots of whatever B is. Actually, let's change it to a minus rather than a plus. So let's change that to a minus. So minus 2 lots of B. So that would be B, we said, was 7, negative 5. Right, so we can work that out. 3 lots of A would be negative 9, 6. And I'm taking away 2 lots of B. So that would be 14, negative 10. And my final answer would then be negative 9 minus 14, which would be negative 23. And then 6 minus negative 10, because we've got 2 minuses here, minus a negative, that becomes 6 plus 10, 16. Okay, so this is the first type of vector, vectors as column vectors. The second type of vector is where we've got vectors in geometric problems. So here we don't have the columns anymore. What we have is some sort of diagram, let's say something like this, and we use letters to represent the translation. So we don't need to write down numbers, squares. So let's say we had something like this, and I had another vector that went there like that, and let's say I wanted to work out what this vector was here. Well, let's think about it. To get from this point to this point, how do I get from here to here? Well, I go backwards along A and forwards along B. I know it's the long way round, but as long as I start and finish in the right place, that's all that matters. So when I go backwards along B, we write that as negative B, and then forwards along A, we write that as plus A. So this vector, or that negative B plus A, represents this vector here. If I had a point, let's put an X there, and let's say this point was halfway. Let's put some letters on this now. Okay, so if we go back to what we've just done, I just worked out the vector that takes me from point B to A. So the arrow shows that I'm doing that, and that was negative B plus A. let's say I want a vector that goes from O to M. Now O to M is halfway. Well, I was going to put half here. Let's put half in. OM is halfway from O to B. Now, how do I get from O to B? Well, O to B is just B. So O to M is just half of B. Let's say I had another point here, and let's call this point Y. And let's say that the ratio of these two bits was 2 parts to 3 parts. Okay, so I could say that the ratio from OX to XA is 3 to 2. Now I can use that to work out the fractions. If this is 3 parts and this is 2 parts, this is 3 out of 5 parts, 3/5, and this would be 2 out of 5 parts, so that would be 2/5. So I could say something like, let's change that. I did use the letter Y, so I'm not sure why I'm putting an X, so let's change that to Y. So I could say that O to Y is 3/5 of how I get from O to A, which is just A. It's just 3/5 along that line. And I could say that YA is 2/5 of how I get from O to A. Now let's say, for example, I wanted to find out what this was. I wanted to know, how do I get from M to Y? So I want to go from M to Y. Now there's no direct route, so I go along this route here. So I'll start at M, I'll go back to O, and then from O I'll go to Y. So that route is going to take me from M to O, and then it's going to take me from O to Y. So you can see I do start at M and I finish at Y. I go to O in between, that's not a problem. Now O to M is going backwards along half of B, so negative half B, and then it's forwards along 3/5 of A, so plus 3/5 of A. So that's what the vector from M to Y would be. Now one or two other things with vectors we need to know. One of them is proving something is a straight line. So with vectors, if we have straight lines, if something's going to be on a straight line, and we've got like 3 vectors, so straight lines, what we do is we have vectors which are multiples of each other, vectors which are multiples of each other are parallel. And if I've got vectors which are parallel, if they start at the same place, so if they start at the same place, then it means we've got a straight line. So sometimes we get questions, it says prove something is a straight line. Well, all we need to do is to show that I've got vectors which are multiples of each other, and multiples means they're parallel and they start at the same place.